Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap today with some really fascinating information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. Following today's presentation, we will be sending out an email that contains a link to access the webinar. And we are taking questions from the audience. So if at any time during our presentation you have a question for our panelists, please don't hesitate, just use your GoToWebinar control panel and submit your questions. We'll take a few minutes near the end of the presentation and go through those audience questions. And finally, everybody who attends today's webinar is eligible to enter a drawing for one of 5 $50 Amazon gift cards. We'll be doing a random drawing at the end of today's presentation for those 5 winners. So best of luck to everybody who attends. Okay, with that, we'll kick off today's webinar, which is Scale DevSecOps with your continuous integration pipeline. Our speakers today are Vinita Puranik, who is Vice President Engineering, SaaS Ops at Veracode. And she's going to be joined by Janet Worthington, who is Product Manager at Veracode. Welcome, ladies. Thank you for joining me today.
Hello.
I know great. So we are going to actually get things kicked off with a poll question, and then we'll dive right on into today's presentation. I'm going to go ahead and launch today's poll. And there it is right up on the screen. I hope the audience will participate for us. The question is, what is your role on the team? Are you a developer and test, security, DevOps, or manager? Go ahead and submit your answer, and we'll take just a few seconds to let the audience do that, and then I'll close out the poll, take a look at the results, and then Vinita, I'll go ahead and turn it right over to you. So. Also, also want to remind the audience, anytime during our presentation, if you have a question, you don't have to wait until we get to the Q&A period. So you don't have to wait to submit your questions if you have any. So you can do that anytime during the presentation. Okay, let's go ahead and close out the poll. Looks like those who are going to participate have already. So I'm closing it, and here are the results. The majority of folks are DevOps folks. So Vinita, I hope that helps you as you understand what the audience is made up of. So I'm going to go ahead and close or hide the results and let you get to it.
Hi, everybody. I'm Vinita. I lead the static analysis team, Greenlight team, and e-learning team here at Veracode, along with production operations for these products. We're talking today about DevSecOps and how to implement this program and effectively scale it. Can everybody see the screen now?
We are good to go.
Thank you so much, and sorry about that, guys. I'll speak from my own experience of executing such a program in our teams. Let's set the context first, define the term, and what it has come to mean. Some people define it as a collaboration between engineering and operations throughout the software cycle, while some define it as operations teams are now writing infrastructure as code and using development-like techniques. And security is now an integral part of this cycle. Well, whichever definition you go by, DevSecOps culture provides the right environment for continuous improvement, efficiency, and high performance, and moves the security left towards the developer, meaning helps address security issues early in the software cycle. This allows organizations to deliver value to the customers faster and with higher quality, which is the ultimate goal we all have. Very often, companies can use COMS, a framework that is often used as a maturity model. It helps managers to evaluate whether or not their organization is ready for DevOps, and if not, what needs to change. The 5 pillars of this framework are culture of shared responsibility, automation, this means automate as many tasks as possible, and developers are comfortable with the idea of continuous delivery, lean, which means the team members are able to visualize work in progress limit batch sizes, and manage the queue length. And then measure. Data is collected on everything, and there are mechanisms in place that provide visibility to our system. Last one, the S stands for sharing. There are user-friendly communication channels that encourage ongoing communication. So let's look at Veracode. At Veracode, we have embraced this philosophy. Let's look at the characteristics and behavior of a team that follows this methodology. DevSecOps is a whole new mindset, a new way of working, if you will. Value is delivered in small increments in a continuous and speedy manner. Agile teams work on small features and release them as soon as they are ready. The key word here is value to customers. No more waiting for months at a time to give customers what they're asking for. The speed in this delivery can only be achieved by automating wherever possible. All functionality should be covered by this automation to gain confidence in the release. Automate your tests, automate security tools and other code quality tools. Automation should be part of build process, deployments, and monitoring. From concept to production, avoid manual steps where possible. Guys, computers are always faster and more reliable than humans. Security testing should be seamlessly incorporated as part of this workflow and automated as well and made actionable. For example, turn your static scan results into Jira issues. Fail your build when security issues are found, just like a compiler would. Give your developers a tool that shows security flaws and tips right inside their IDE so they know where the flaw is and how to fix it. That is what we mean by actionable. Otherwise, it is a security flaw that sits in some CISO's report that you only see at compliance checkpoint. A typical Agile team has multiple skill sets right on the team. We would typically have a product owner, scrum master, user interface developer, documentation person, developers, some with security skills, QA, operations. They are all heavily collaborating through all phases of development. They retrospect and learn and continuously improve together. Building trust is an integral part of any team. Everyone on the team should innovate and experiment. Life happens and things fail. In a trusting team, you build fast, fail fast when needed, and get a quick feedback and improve as you go with what you have learned. All of the above results in a very effective, efficient, and lean process for software development. Delivering new features at high velocity means happy customers and also product managers, right, Janet? So look at this chart. It's a new way of looking at what you're measuring and what the development is. The chart above is showing you a comprehensive view of how software is developed and measured today. Software development process is important, but pay just as much attention to your deployment metrics and make deployments automated and easy. Also make sure that you have good operations and monitoring practices implemented to ensure high availability in production. Efficient development cycle with heavy test automation allows you to be ready for release faster. If you automate all your deployment steps, you can now release the software multiple times in a day with confidence. No matter how good the guardrails, systems do run into issues. This automation also allows for fast rollback or rolling out bug fixes. Faster rollout equals less downtime or disruptions in production. Automating your operations and monitoring means fast, proactive response to production issues and higher availability for your customers. With automation at every step of the way, you can measure how you're doing with your DevSecOps implementation and improve as you go. Implementing new philosophy is not easy, but seeing the impact of this change in numbers is a great motivator to keep going. Enjoy these small successes. Measure uptime, number of times you release, time it takes for you to recover from an issue. As you track these and see them improve over time, adopting this change becomes much easier. Here is some independent data that supports how working in small increments through the whole cycle makes software development efficient.
So, Vanita, do you have any teams that are actually seeing these benefits?
Yes, very much. Greenlight team, that's the one tool that you're going to be reviewing very shortly, is a fully DevOps team and is capable of releasing the code multiple times a day if needed. They release as soon as the feature or a bug fix is ready. What we are getting as outcome is throughput, which is frequent code deploys, and stability, which is less failures and faster recovery. So let's break these down. All the 3 steps that we reviewed. What we talked about was development, deploy, and operations. And look at how we at Veracode implement this methodology in our greenfield teams. The Agile engineering team that implements Greenlight is cross-functional. It has all those different cross-functional resources I talked about: QA, developers, UX, IT. Even security knowledge is built right within the team. With all skill sets available in one team, design takes into consideration infrastructure and security details, and work flows faster without impediments. There is less inter-team dependencies and handoffs, both of which always result in reduced velocity. Teams plan implementation and release work in short bursts. It's an Agile team. They also plan for test automation right with that, as well as operational monitoring of services and functionality when they're grooming and developing features. We have seen quite an evolution in development lifecycle in last 10 years. It started out a while ago with monolithic architectures, and I'm sure many of you are still probably dealing with those. Team used waterfall lifecycles and developed on-prem products. Along came N-tier architecture, app tier, web tier, business logic, databases. Code complexity increased. Agile methodology became common, and teams switched from waterfall as they realized the importance of working in smaller increments. SaaS concepts came along, and many started hosting services in data centers. Now, many teams are moving to microservice architectures and DevOps methodology and are using public cloud, for example, to run their code. For example, at Veracode, Greenlight team runs in Amazon AWS as microservices on EC2 instances, and we use Lambdas. This has enabled us to scale to thousands of scans concurrently. Today's DevSec Ops teams use non-monolithic modular microservice architecture. There is 100% automation for functionality and infrastructure that makes it very maintainable for fixes and features. All this automation means the teams can deploy as often as needed, down to every hour. This is very powerful. You can deliver fixes and features that is valuable to your customers as often as you need. No waiting for service packs or next release a month or a quarter away. All the infrastructure is also implemented as code. What does that mean? Deploying new instances, queuing logic for jobs, auto-scaling for cloud instances are some of the examples that are coded now. Our teams have been using Python to write this code. So let's look at the second aspect that we looked at, CI/CD. And as we saw, a lot of you are from that DevOps people. So you know how important this is. CI/CD stands, of course, for continuous integration and continuous deploy. If you want to be release ready at all times and release as often as needed, embracing this methodology is must. It's very important. On our team, here is the process we follow. The development is performed on a separate feature branch. It matches the existing Jira ticket, which is what we use for our issues, for tracking purposes. Developers are empowered with the tools like Veracode Greenlight. They can run it inside the IDE and get immediate security feedback as they write their code. They can also increase their security knowledge about these issues using help available right within their IDE. Development branch can only be altered via merge requests. No direct commits are allowed. Merge requests must pass a successful build, which runs unit tests, smoke tests with it. Merge requests must also have two human approvals. Code reviews are an important step to ensure good quality. All new code must have automation tests that cover the functional as well as infrastructure changes. I'm describing all this because these are important steps if you want to get the automated deploy and feel confident. Merge to development branch auto triggers a build for all artifacts required for release to development, QA, and production environment at the same time. We use what's called canary or blue-green deployments. If we are currently on development version A and want to move to a new version B, the second environment is stood up on the side, fully independent of each other. The DNS traffic is slowly routed from A to B in production, monitoring for PagerDuty alerts that we have programmed into our infrastructure code. We also monitor matrix dashboard for errors. If traffic reaches 100% to B and there are no errors for 15 minutes, we are good to go and we take A down. If at any time there is an error or alert, traffic is set 100% back to A, easy rollback, and B is left up so that the team can quickly diagnose the issues. So now let's move on to the last one of the steps that we talked about, which is operations. As the new features are developed, team designs tasks needed for good operational monitoring. For example, performance tests are added or augmented. Team also maintains code that logs matrix and logging for debugging when an issue occurs, which is what is going to allow you for fast recovery. Math is your friend here. Monitoring stats helps you plan improvements for operations in a better way. Stats around what is running, when is it running, how often. These kinds of things help you stay one step ahead of production issues. Early in the design, the team considers questions that in the past would have been addressed at release time or sometimes post-release when production issues were seen. For example, what is my deploy strategy? How often do I want to deploy? Will it require downtime? How do I avoid downtime? Will it scale and perform with the number of users or actions as thousands of requests concurrently come in? What is my instances capacity? Is it efficient? Is it sufficient? Is it cost effective? Making customer experience the best possible in production environment is part of the design now, and you're also looking at your CapEx and OpEx by designing it properly. Operational data is saved, and errors are monitored, and alerts are created automatically. We use PagerDuty. Team gets rapid feedback about new feature and learns, and if errors are found, the fix is deployed fast. Since the feature and fixes are deployed in small increments, we can fail very quickly and fix with speed. There is a big culture change in the team. There is no skill-based silos anymore. Testing, operations, security testing is everyone's job every day and not for select few. We will review our security process in detail in the next slide. We have seen a cultural shift though in our teams. They feel closer to the customer. Teams are now very aware of customer successes and issues and feel accountable and responsible to respond fast to these issues. This close connection to the customer and feedback loop actually makes team members happier. Knowing how your code is functioning and being utilized is a great motivator. So, as promised, a little bit detailed view of security. Let's specifically focus on security part of the DevSecOps. In recent years, we have seen increased awareness about security in all software companies. The change we need now is to move from reactive culture to proactive culture.
Okay, Vanina, so what does a proactive culture look like?
Okay, so with the new awareness about security, security is a gate for most teams before they release. But it's no fun fixing hundreds of issues found just when you're done with your software cycle and you're ready to release and move on to your next feature development. It can delay deployments. So we have made several changes in our teams to avoid this hockey stick effect. We are running these security tests much earlier, starting when developers write code or as they build the code with their CI tools. Security issues now can show up just like their compile issues. Very important here is to empower your team with right tools. Second, just as important aspect is to empower your teams with knowledge. Just like developers know about design patterns and programming languages, make the common security issues part of their skill set. We have e-learning courses available to empower our developers to learn about security right as they find the issues. So for example, if you have a security flaw of type SQL injection, Veracode tools give you one-click access to more information about the flaw and how to fix it through quick tips and code examples and courses. By the way, security knowledge is becoming a fast, very important skill on your resume. So there is another motivation for everyone. Communication is very important when any issue happens. We have made it easy for teams to monitor for errors from builds or production errors by sending these alerts on any failures in chat channels. As you know, chat channels are getting very popular for people to see this. Communication is very important. Third, and very helpful for any initiative, is to create a team of security evangelists. The champions, the security champions who are skilled security professionals, are embedded right within the teams. You can call anybody at Veracode to find out more about the Security Champions program. It helps us to have someone in the Agile team that you can go to when you have security questions, the ones who will keep up with security industry and infuse that knowledge within your team. They can bring enthusiasm around security. Last but not the least, empower your developer. Give your team control of this process with right tools. As Uncle Ben said to Spider-Man, with great power comes great responsibility. Well, guess what? It's very good for your developers too. With empowerment comes the responsibility and accountability for fixing these quality and security issues early as part of your dev cycle. You now have metrics for your security, just like you have them for your incidents and bugs. Development managers are happy without that hockey stick effect at the end of the project, and CISO and security managers happy because they get policy compliance fast. Win-win for all, wouldn't you say, Janet?
Yes, and you guys have done a great job of realizing the promise of DevSecOps and how it helps organizations like Veracode deliver value to our customers faster and with higher quality. I guess I'm wondering, what's the impact to developers? I read a report recently by Stripe that surveyed thousands of executives and developers and found that developers spend on average 17.3 hours a week dealing with bad code, debugging, looking at errors, and technical debt. From what we understand, DevOps embraces the lean methodology of eliminating waste from the system with automating repeatable tasks, like Vinita talked about, tight feedback loops, and integrating quality throughout the process. As Vinita was saying, this also holds true for security. As Vinita teams have seen, by incorporating security throughout the lifecycle, they have reduced the need for developers to have to go back and fix security defects or rework code to meet security standards. In fact, the Puppet Lab State of DevOps states that high-performing teams like Vinita's spend 50% less time on remediating security issues because they address security at every stage of the software development lifecycle instead of retrofitting security at the end. So for developers, this means you're spending less time on fixing bugs and security issues, giving you more time back. So Vinita, do developers typically enjoy spending time on fixing bugs and security issues? What do you think they prefer to do with their time?
Nice trick question, Janet. Of course, developers love to work on new features whenever they have the context switch and go back to legacy code and fix flaws identified in late cycle when they're not happy. Fixing it in time is the good thing.
Makes sense. And as a product manager, I'd like to have them working on new features. Are there any other benefits to developers with the DevSecOps?
So security knowledge you have seen it in the news. all the companies care about it. It has become very mainstream. When you understand security issues, fix them, and how to use, how to use these tools, it's a great add-in to anybody's resume.
It's great. So it's a win for everyone. So fail fast, fail often, as Vinita has been saying to her teams. The evidence of why this is important was released in Veracode's State of Software Security Report from 2018. It found that DevSecOps programs fix flaws more than 11.5 times faster than typical organizations. This allows them to improve the security posture of their applications and reduce risk for their organization without decreasing development velocity, which is important, of course, to us product managers. So what does it mean to do security throughout the lifecycle? At different points in the application lifecycle, what we ask from a quality perspective changes. When a developer is coding in their IDE or editor, they're focused on what they're working on, being able to test their work quickly and to answer the question, is my code good? And from a security perspective, is my code secure? So you write unit tests alongside your code, and we would do the same for security. Once your code is checked in and integrated into the main branch, the question that the team asks is our combined code good? Is our combined code secure? This is typically where, in the process, a team might run their functional or integration tests. Then, as the application passes different checks moving towards automated deployment, the question that the development and the security team ask is my code good? Is my app good? And secure. At this point in the process, you may even be running UAT or your final validation test. Here, the coverage of tests will help ensure that you won't be introducing poor quality code or security risks into production. Early stages in the development lifecycle, speed and preventing new flaws from entering code downstream is critical. Later in the cycle, prior to release, understanding the full security posture of your application and ensuring that it meets security standards is the priority. Veracode's products were designed with these concepts in mind. Greenlight focuses on speed and flaw prevention for the developer in their IDE or editor, and soon, as we will talk about, in the CI lifecycle. Veracode's Static Sandbox helps teams like Vinita's Greenlight team to get a preview of their project before it moves down to the final stages of testing. And in those final stages, where coverage is most important, they get that full assurance by looking at a static policy scan on their application. So let's dive a little bit more into Greenlight. So as I mentioned before, Greenlight helps answer the question, is my code good? Providing fast, focused feedback early in the coding lifecycle with remediation guidance in the form of code examples that walk developers through why an issue is what SQL injection, how a hacker might be able to use SQL injection in order to penetrate their application, and most importantly, giving them code examples on how to fix a code so that they no longer have a SQL injection. Additionally, Veracode Greenlight provides AppSec tutorials that allows developers who prefer to watch videos to fail fast and learn fast, all in the privacy of their IDE. Developers have the opportunity to fix their flaws before their code is committed to the repository and integrated into the larger feedback. By providing feedback on potential issues, as well as Veracode provides best practices when a developer is using an industry secure coding practice, helps developers to learn while they're still developing features and functionality for the business. This reduces the potential for future unplanned work and increases developer velocity. So those of you who are familiar with Veracode Greenlight, you're aware that we today have plugins into the IDE so that developers can get that fast feedback and learn as they code. We support a number of IDEs. Vinita's team works very hard, as you can see, to support many of the popular ones like Eclipse, IntelliJ, Visual Studio, and Android support, just to name a few, as well as the support for many languages, including Java, .NET, and JavaScript. Knowing that integrating security into the DevOps toolchain is the best way to seamlessly incorporate security we are now also offering a Greenlight API. On top of this, Vinita's team has created a CI tool that allows development teams to easily plug it into a GitLab or Jenkins, for example, system so that it can run Greenlight on changes. The tool itself supports Jenkins and GitLab, as well as the language scanning of Java and JavaScript. If your teams are interested in using the tool, we suggest you try it out. And we also, if you prefer to integrate it at a different point in the process, can use the Greenlight API. So let's talk a little bit about the DevSecOps pipeline. As Vinita mentioned, her team runs static scanning as part of the pipeline. Along the way, her teams have started to run Greenlight earlier in the process so that they can adopt her mantra of fail fast, learn fast. As we mentioned before, in the IDE, developers are coding and they want to understand information about their work. And so they'll find out about compile errors and run their unit tests, again, all in the privacy of their IDE. This is where Greenlight can also provide that feedback from a security perspective. In the DevOps lifecycle, as Vinita mentioned before, her team embraces the small batch sizes. What that translates to, according to Randy Shoup, who is a DevOps guru, is into tiny commits in the software world because the risk of change is smaller. According to Randy, a 10-line change is not half as small in terms of risk as a 20-line change. It is actually a quarter smaller. Why? Because this fits into your brain, a smaller cognitive load, and it's easier to understand and fix. At the coding stage, speed is paramount, and as is limiting distractions. So that is why when you move into the integration portion of your DevSecOps lifecycle, you want to make sure that you're getting frequent feedback on a commit or a merge before it moves downstream. This can be triggered typically on a feature development or master branches. You would be running your builds, your unit tests, code quality, and Greenlight as well on those changes that have just been checked in. This allows teams to get that feedback and fix issues before the code is integrated into the larger project. Similar to when a build fails during the CI phases, developers will fix flaws immediately in the pipeline. Teams can use the Greenlight CI tool at this point to fail a stage based on severity flaws that are returned. Once a feature has been iterated on, it will likely be merged into a development or master branch. Here is when we start thinking about continuous testing, when functional tests, integration tests are all being run on our project. The goal at this stage is to make sure that the feature that we just wrote didn't disrupt any of the quality that we had before. This is where teams will automate a lot of their testing, and if there are failures, as Vinita mentioned before, those failures go back into a defect tracking system that flow into a Scrum backlog to be picked up in the next sprint. If this phase passes, then you might automatically have it tagged for release, or depending on your approval process, there may be a manual step to trigger the final validation steps where you're going to be doing a final staging, UAT, and a static scan on your policy level to ensure that your application is meeting your security standards. So all this is great, but what I'd like to do is to show you right now an example of this in GitLab, which is a continuous integration system. I am going to try and attempt to do a live demo, so I'm going to momentarily pause the actual presentation while I bring up GitLab. I feel lucky that this is all going to work out because I have a VP of engineering sitting right next to me. So this should all happen seamlessly. Let's see. Well, Vinita, you are good luck. So what you're looking at right here, this is GitLab. For those of you who are familiar, you've probably seen this before. it is similar into Jenkins, if you've not seen GitLab, in the sense that it does allow you to kick off your continuous integration, continuous deployment processes. In what you're looking at right now is a number of different pipelines that have run. Vinita's team actually has different pipelines based on the, you can have it based on the branch, as well as different activities that will trigger different jobs in the process. I have a feature branch here, and on the feature branch, we run a number of tests while we're iterating on the code. We also have a master branch that runs a series of tests, and when all that passes, we then go and tag for release. On all of the branches, Vinita's teams make sure that they run build unit tests, and as you'll see, code quality tests and security tests like Greenlight. So to kind of give you guys a better understanding, I'm actually going to go and I'm going to pretend, normally if I were a developer, I'd probably be coding in my IDE or my editor and push my changes to the feature branch. For the sake of the demo, I'm just going to go into a file. You can edit files with GitLab, so I'm just going to edit this flawed.java file, but normally, again, I'd be on a editor. I'm just going to put a comment in so that it triggers a change, and I'm going to submit that. So I come down here, and I'm going to commit my changes. What this will do is this will kick off that feature branch workflow. And you will be able to see, let's go to my pipeline so you can actually see my feature branch running. So this is my feature branch. I just modified that flawed.java file, and as you can see, it's starting to run the stages. The first stage here is unit tests. We run, as I mentioned before, unit tests on every single branch. Then we do a build, followed by code quality tests. So for example, we do linting on our files to make sure that they are meet particular standards that Vinita and the security team have set up. And then we run a Greenlight scan. So it's taking a little bit of time just because it is running. So I'm going to actually go and look at a feature branch that has already scanned, so you guys can see just really quickly what that looks like. So you see the unit test, the build, the code quality, and then the Greenlight scan, which passed. Now, let's say one of my Greenlight fails. Let's say it found flaws. What would that look like? So let me go down to one that has already been run before. And as you can see, the Greenlight stage failed. And let's look at why. What you're seeing now is a console window. Most CI systems do have a console window. If you were a developer, this is where you would look at something similar if there was a build failure or a unit test failure. What the Veracode CI tool does, though, is it summarizes the information for you. I'm going to start by saying this is a particularly buggy file, this flawed.java, on purpose. We do not anticipate that this is a normal setup here. And what we're telling you is that we found 5 best practices in your code. We actually tell you the name of the package and the file down to the line number where you've actually done a good job of writing code to protect against something like a cryptographic issue. From a flaw issue, we see that we found a total of 9 flaws. We found 1 issue of low priority or severity 2, 6 of severity 3, 1 high, and 1 very high. So I'm just going to look at the mediums right now here. And what I see is Veracode again is telling me the CWE, which is the common weakness enumeration, which is used by MITRE to identify security flaws. And it's something that you can look up as well. It also is giving me the insufficient entropy is the high-level description of the issue, along with, again, the package and the file level down to the line number. As a developer, this means that I'll be able to go into my code and fix it. Now, as a developer, if I want to get more details, so this is summary level, and it can tell me why things are failing. It's because I found these flaws. I can actually set thresholds. Different teams have different requirements early on in the continuous integration lifecycle when code is being integrated quickly. So right now, the Greenlight tool has been set to fail on any issue that I find. But what we see, and especially I notice with when I'm working with the Greenlight team, is that when they put a new check in, whether it's a code quality check or security check or performance test, is that they put it into their system first, and then they start ratcheting up the requirements. So you might put Greenlight in and not have it fail to begin with, just let it run a couple of times, and then you might start ratcheting it up so that it only fails on very high issues, and then you might include high, et cetera, as you go along. It gives teams the ability to kind of look and understand the Greenlight and other types of tools in their process. And again, different projects may have different requirements, and all this can be set at the pipeline level. And so, as I mentioned before, if I was a developer and I wanted to get a bit more details, what I can do is I can actually go and look at the JSON file that is returned by Veracode Greenlight. So we saw the summary level before, but if I wanted to get the more detailed level, I can download the Greenlight artifact, which is, again, the JSON file that's saved in my CI system. So let's say that I see what my flaws are, and then I go back in and I save it. That's going to, again, kick off another run on the feature branch. And this time, it passes. What happens next is I'll iterate, as a developer, I'll probably iterate on my feature branch. And when I'm ready for that feature to be integrated into the master branch, I'll issue a merge request. As Vanita pointed out before, that merge request will require that 2 approvers, as well as it will mean that my pipeline has to be passing. And as you can see here, it is. So that means my merge request will go through successfully. That then kicks off the master branch pipeline. And if we look at the master branch pipeline, the way Vanita's teams have set it up is that you're rerunning all of your tests again, because when you're merging code, you need to always validate that nothing has happened. And in this case, we're rerunning again all of our unit, our builds, our code quality, and Greenlight. And if that all passes, we then tag for release, and that will go out and run our release pipeline. And let me just show you quickly our release pipeline. And so what the release pipeline does is it runs, we're going to now run the jobs and stages that are important for that continuous testing part of the life cycle. So you have, you saw the beginning of the pipeline there. Now we're uploading to Lambdas in order so we can do a deployment there. We're going to then now run our integrations test on this master branch. If these pass, we then do a number of different types of checks, including Sonar Cube, Source Clear. Sonar is quality, Source Clear is open source technology to make sure our third party and open source libraries are correct, and then a static scan. Then, if those all pass, we are going to run our stage, and we're going to deploy to stage and run our performance and smoke test. In this life cycle, if all of this passes, this is just a sample pipeline that we have here. What would happen is there would be an automated step to then deploy to production. So you might be asking, well, this looks really good, but how hard is it to actually integrate this Greenlight tool into our pipelines? Well, I'm going to show you what it looks like in GitLab. It's just as easy in Jenkins because Vanita's team has worked very hard to make it simple so that even a product manager can understand what's going on. I'm in what they call the GitLab YAML file. This is where you, and I skipped really quickly, but this is where, for those of you who aren't familiar, you create your stages and the jobs that are associated with your stages for your YAML file. As you can see here for Greenlight, this is the Greenlight stage and then the Greenlight job that we're going to run. The actual, what we do is we do a curl command to download the tool called GL Scanner Java, and it always pulls down the latest, so you don't have to worry about maintenance. We unzip the file, we get the tool, and then it's simply a Java tool that runs. It's important to note that you do have to pass Veracode ID and key, so there you know that this is authenticated, and you can pass these all as parameters, including the project name and project metadata information. So it's as you can see, it's very simple. This is actually one line of code. It's easy to do in GitLab, and it's easy to do in Jenkins. So now I'm going to switch back to my presentation so we can finish it up, and then we can open it up for questions. So I'm just going to, sorry, one second. So if you're interested in Veracode Greenlight, and you can go to our veracode.com, and you can actually try a free trial. It's clips. It's all automated for you. Or you can contact our sales team. Also, Vanita and I have put together some of our favorite DevSec Ops resources. The DevOps handbook is the Bible here at Veracode. We also use the DORA State of DevOps. There's a great AWS case study where AWS came in and they were so proud of how Vanita's Greenlight team was using AWS that they wrote a case study on it that you can all look at. The State of Software Security I mentioned before is the 2018 version. That has come out recently, and you can find more information on our website about it. And finally, we have a DevSecOps Galaxy guide for developers. So I think I talked for a while there, and I think we're going to open it up now for questions.
Yeah, we've gotten some great questions in so far, but there's still time, guys. If you have a question for either Vanita or Janet, please go ahead and use your GoToWebinar control panel and submit the questions. Let's go ahead and dive right on into them. The first one, I have noticed that many companies are doing this now, except they are failing often after they send the code to the customer. So where, and then I guess as part of that, where is the Q&A? Oh, sorry, the QA, not Q&A,
Okay.
QA.
So the question was, is it that they're failing after the release and not before?
Well, that's an observation that he's had, yeah.
Right. And that's true. That is why we covered it when we talked about it. That, of course, and that's going to happen too, by the way. But having all these steps that we are talking about before the deploy or proactively staying ahead of it is what is going to stop you from failing in production. Now, it's still the life will happen. The QA is part of the Agile team, by the way. We call them as software engineers and test. They're very much on the team, and they are doing automation along with developers in every single sprint. So absolutely, we do. There is some philosophy out there where developers are writing tests. Most of the time, they are in our teams too. They cover a lot of unit tests. But what we use our automation QA engineers for is the integration end-to-end test so that they can look at your QA strategy to get that functional confidence when you release.
All right, great. Next question then. Let's see, why did you say create security champions? Do you believe security personnel for DevSecOps should come from within the security team or outside?
Nice question. So what we realized when we started out, we do have a security team. We have people that are very experts, but you can create an almost like a single point of failure or everybody's impeding on them. So what we ended up introducing is a security champions program, which is where the experts in security, which were in security teams, created the team of people, one from every Agile team, and we rotate, and they trained them with security knowledge. They do some games online, they read books, they hack and check how they would fix it. And so what we did was, outside the team, you need experts, but we also created experts within the teams, and that's what we call security champions. And what we noticed was, once you have it on every team, the evangelist, that's the only way to grow and scale. Your security team can't scale with your Agile teams. I mean, some companies nowadays, you have a department of 300 developers. So you do want the knowledge within the teams too. So it's a combination thereof.
Excellent. Okay. Next question. Can you talk about how you define the unit tests? And how do you define the Greenlight tests?
Okay, so I'm going to, so Janet can go to the Greenlight test. Greenlight is a tool that runs on it, so I'll let her define it according to how she demoed it. So unit test is how any QA or a developer knows it, where you write a functionality and you immediately write a test that actually tests your function, which can run with your build. Greenlight test is looking for security flaws. So developer is not writing it. Developer is running that tool that we have, the expert engine, that will look through your files and bring back the results to you as flaws. And so we call it a Greenlight test, but what that step really means in your CI pipeline is where it is going and running the engine against your little piece of code that you just changed. Does that explain it?
Yes, just to add to Vanita, what Vanita's saying is that we talk about security tests and how they dovetail into quality tests. And so likely you'll be running Greenlight in the same places where you're running your unit tests. As Vanita pointed out, though, unlike unit tests, you don't have to write them. The Greenlight scan happens for you. But Greenlight will look at a file or a package. So it's looking at a smaller portion of the code than our static engine, which looks at the full application and provides you that coverage and depth that you might think of more akin to if you were doing regression testing or integration testing.
All right, great. Next question then. What kind of database do you use for CVEs or identifying risks?
Okay, so we can take it combined, the answer. So there is lot of information out there for what the standard defined vulnerabilities are, and you can Google for it and you'll get what is a SQL injection, what are some other type of flaws. But what we do is not refer to that. We refer to that database to give you a standard ID for the vulnerability. The way we find the vulnerabilities, though, that is the Veracode engine, the secret sauce. We are able to actually look at all the paths through the code to identify where the risks are and point out the standard ID of the vulnerability that you have in your code. And that's the engine, the algorithms that we have that find it. So database only gives you the numbers, the standard IDs.
Okay, great. Next question, does Veracode do container-based security?
It's definitely something that we're actually looking into right now is with our software composition analysis product, and I think we're going to have some announcements very soon around that. It'll look at your libraries, open source and third party on your container. So coming soon.
All right, stay tuned. Watch this space. Okay. Let's see. Okay. Let's see. The question before that we talked about the unit test and the Greenlight test, there's a follow-up from that person. It says, thank you for explaining that. I was looking for what language you are using to write the tests, or are you using a GUI?
So I assume you're talking about, for unit tests. It depends on the people that are using the language they're writing the unit tests in. So Java folks are using Java for writing their unit tests. There is also Selenium and GUI test, but they usually don't run with the build. Those are your integration tests. Is that what the question was?
Yeah.
When it comes to static or Greenlight, that's where our algorithm is running, even though it's called a test. So you are just invoking an API or a call to our engine to give you back the results.
Okay.
We use all kinds of languages when we write our code, Java and Python being the majority.
Okay. All right, great. Okay, next question. Once we make use of Greenlight in IDE and in CI, do we still need to do a SAST and DAST, and then how do you automate that in the CI/CD pipeline?
Okay, so two parts to it. The first question is, do you need it? Yes, you do. Here is why. The whole idea of shift left is you do this early so that you are doing less work later, right? So when you run Greenlight in IDE or in CI, you're looking at the small snippet of changes that happened with the build or what you changed in your file only. What you want to run later for compliance is where you're running the whole application. And what changes is when there are calls coming, there is a huge call stack where your call may go from jar to jar, file to file, even in completely another area. and that gets picked up in the bigger compliance scan. So the first one augments the latter one, it doesn't replace it.
It's kind of similar to if you think about how quality testing works, where earlier in the life cycle, you run unit tests or smaller functional tests that you can prevent flaws from getting in. And then later on in your life cycle, you're going to start building on those tests. You run integration tests to see how the modules within a project work together or modules between projects work together. And then later on in the life cycle, you'll run larger validation, maybe a regression test, or even UAT tests. And so each time as you're running tests, you're sort of building on them. So you're looking at a larger scope of the application, and you're getting a larger coverage. So you need to run, both are important to be run, and static can be integrated into the CI/CD pipeline. In GitLab, the example that I have, I upload to static in what I would call the continuous testing part of the pipeline. And right after we do integration tests, you can kick off and upload to the Veracode static engine.
All right, great. Well, we're about 2 minutes to the top of the hour, so we're going to have to close out the question and answer period for today's presentation. I do want to remind the audience that if we didn't get to your question, just know that the folks over at Veracode will be getting a copy of all of the questions, so I'm sure they'll be more than happy to follow up with you offline. But we promised at the top of the hour that we would do a drawing for 5 $50 Amazon gift cards, so I want to go ahead and do that now. Drum roll, please. Okay, our gift card winners. First one is David Daskmut, and I apologize if I mispronounced your name, so congratulations, David. Next person, big winner, is Frank Mevison. Frank, congratulations, Frank. Third winner is Poonam Kamat, K-A-M-A-T. Congratulations, Poonam. And next winner, Rodrigo Cuevas. Congratulations, Rodrigo. And then the final winner is Tim Van Wees, I think it is. Congratulations to Tim. All right, great. So there are 5 winners for today's gift card drawing. Congratulations. We'll be contacting you offline to get that squared away. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, you will be able to listen to it on demand. We'll be sending out that link that you can access it on demand following today's presentation. The webinar is also going to be living on the DevOps.com website. So if you you can always check it out there, and it should be right there waiting for you in the webinar section. Just click on the on-demand section and there it will be. While you're there, please go ahead and take a look at the other webinars that we have both upcoming and on demand. Vanita and Janet, thank you so much for giving such a great presentation today.
Thank you.
Great. And thank you to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.